Hello everyone, welcome to today's math class. Today we have this challenge before us here. The question is it's an algebraic expression and it's an algebraic equation. How do we solve this? The question is 9 times the t root of 4 plus 8 times the t root of 9 equal to 22 times the t root of 6. What is the value of x here? Alright, so let's take our solution here. The solution. Now before we continue, if you're new here, do not forget to subscribe. And when you subscribe, hit the bell notification button so that the YouTube algorithm will notify you whenever we drop an amazing video, because here we release videos every day. All right, so now look at this question here. With what we have here now, we can just rewrite this radical here, okay? So let's go ahead and rewrite this radical. This is 9, okay, times our 4 all to the power of 1 all over t, there plus our 8 times the bracket, our 9, all raised to 1 all over t, equal to, we are having 22 times our bracket up here, our 6, all raised to 1 all over t, not 6, please, this t. Okay, now, with this thing we have here now, I want to divide through by 4 to the power of 1 all over t, okay? So let's divide everything here by our 4 to the power of 1 all over t. Then we equally divide this by 4 all raised to 1 all over t. We do same thing to the left hand side, sorry, right hand side of the equation. Okay. Now with this thing we are having now, what happened? This will go with this, right? So here we are left with 9. So let's just go ahead and put down the 9 there plus, look at what we're having here. We're having 1 all over t at the exponent. We're equally having 1 all over t at the exponent. So we're going to apply a simple law which says that if you have your a to the power of your m all over your b to the power of your m, this is equal to your a all over b all raised to the power of your m. Okay, so with this, we want to rewrite this and at the same time rewrite this. So this is going to give us our 8 into our 9 all over 4 all raised to 1 all over t, there equal to our 22 there into our 6 all over 4 all raised to 1 all over t. Now let's look at this again. What do you observe? This is a perfect square. This is a perfect square. 2 can go into 6. 2 can go into 4. So let's rewrite this and also break this down. Okay, so this is going to give us our 9 there plus our 8 into, this is going to give us our 3 to the power of 2 all over 2 to the power of 2 bracket 1 all over t, right? This is equals to our 22, then bracket 2 into 6 will give us 3, then 2 into 4 will give us 2, bracket all raised to 1 all over t. Okay, now let's look further up. Again, if we apply this law, then we can rewrite this expression we have here. So this is going to give us here our 9 plus our 8 into 3 all over 2 all raised to 2, then all in a square bracket raised to 1 all over t. This is equal to our 22 into our 3 all over 2 all raised to 1 all over t. Good. Now, we want to interchange the positions of these two exponents. We are going to apply the law which says that if you have your, let's take your a to the power of your m, n, this is equal to your a to the power of your m, bracket, your n, they equal to your a to the power of your n, the bracket, the your m. So if we apply this rule here, then we can bring this out and bring this in. Why are we doing that? Because we're having 3 all over 2 raised to 1 all over t here. So we want to bring that same quantity here. So this is going to give us our 9 plus our 8, then into, then we're going to have 3 all over 2 all raised to 1 all over t, all in square bracket raised to power 2. This is equal to our 22 then into our 3 all over 2 all raised to 1 all over t. Easy. Okay, we are heading somewhere. Now that we have this quantity and this quantity to be same, we can do a simple substitution. So from here we can say let's take a p. I like using p. So let p be equal to our 3 to the power, 3 all over 2, all raised to the power of our 1 all over t. Okay, so we're going to rewrite this expression here. So this now implies that our 9 plus 8p to the power of 2, okay, this 2, let me write it where, to the power of 2 equal to our 22p. Easy. So let's rearrange this and see the kind of equation we're going to have from here. So this is going to give us 8p to the power of 2 minus our 22p, then plus our 9 equal to 0. So this is a quadratic equation, right? Good. So we want to solve for two values of p that will satisfy this equation. And how do we get that? Because the p square is carrying a coefficient of 8, so for us to use the factorization method, this is what we'll do. We're going to use this to multiply this. Okay? So if we use our 8 times 9, this will give us 72. So what are we going to do here now? We want to look for two numbers from the factors of 72 that when we multiply together will give us 72, and when we add that together will give us minus 22. So that will give us 4 and 18. 4 and 18 will give us what we need. So we have to rewrite this middle term here, and it's going to be minus 4 minus 18. Okay, so this is going to give us our 8p to the power of 2 minus 4p, then minus 18p plus our 9. This is equal to 0. Okay, so we put this in bracket. We also bracket this, bracket this. So let's factor out terms that are common to this bracket and the ones common to this bracket. If you look at this, 4p is common here, right? So this is going to give us our 4p. Then we use this to divide this. This will give us 2p. Then minus, we use this to divide this. We have left with 1. Then minus, what is common here is 9. So we have here 9. Then bracket, use 9 to divide this. This will give us 2p, and minus times plus will give us minus. So yeah, 9 to 9 will give us 1. So we have this equal to 0. What can you see from the terms inside the two brackets? This and this are the same. So we take this that is outside and take this one that is inside. So this is going to give us our 4p minus 9. Okay, minus 9 close bracket, the bracket our 2p minus 1 close bracket. This is equal to 0. Here we apply the zero product rule, which says that your m times n, this is equals to 0. Then it means that our m is equals to 0 or our n is equals to 0. So we're going to take this to 0, take this to 0. So let's take this case here now. So we're taking case 1, right? So we're taking case 1. For case 1, we're going to have 4p minus 9 equal to 0. Move this to this side to give us here 4p is equal to our positive 9. Okay, now we have this to be positive 9. We want to check out, we want to solve for our p. So from here, we just have to make p the subject of the formula. Okay, so we divide by 4 to give us 9 all over 4. Easy. Now recall we said that p is equal to 3 all over 2 raised to power 1 all over t, right? Good. So from this now, we now recall, because we want to solve for the value of t, so we know that 3 all over 2 all raised to the power of 1 all over t is equal to our 9 all over 4. So we're taking this t1 now, sorry, p1. Okay. Now we're having 3 all over 2. Here can be expressed as 3 all over 2 because this will give us 3 to the power of 2 and this will give us 2 to the power of 2. And so we're going to have this to be 3 all over 2 all raised to 1 all over t. This is equal to 3 all over 2 all raised to power 2. The bases are the same. So what happened? So we can equate the exponents. So we're going to have 1 all over t is equals to 2. For us to get t, multiply through by t and divide through by 2. If you do that, this is going to give us t1 is equal to 1 all over 2. So this is the test value of t that will satisfy this equation. And if you put that into this expression, it will give you the correct solution, or it will satisfy this. Okay, so let's solve for case 2 where we have this. All right, let's erase this other side. So considering our case 2 here, so we have here case 2, our case 2. So we have 2p minus 1 equal to 0. So 2p is equal to 1. Divide by 2, divide by 2. Automatically, this will leave. So we have our p is equal to 1 all over 2. So this is our p2. Okay, we'll recall our expression again where we say let p is equal to 3 all over 2 all raised to 1 all over t. So from here, this now implies that our 3 all over 2 all raised to the power of 1 all over t is equal to 1 all over 2. So if you check here now, the bases are different. So since the bases are different, what do we do? The only way to solve this now is to log both sides of the equation. Okay? So I want to take log to base 10 of both sides of the equation. So if I log both sides, it's going to give us here our log. We have here log 3 all over 2 all raised to 1 all over t base 10. This is equal to log our 1 all over 2 base 10. Okay, we apply the law of logarithm, which says that if you have your log your x all raised to the power of your y, then move this backward here. So give us here y times log our x. So if we apply this rule here, then we're going to have this to be our 1 all over t, then times log 3 all over 2, then base 10 equal to our log 1 all over 2 base 10. Okay, so let's continue here and see what this gives us in turn. Okay, we want to divide by log 3 all over 2 base 10. So this is going to give us 1 all over t. Now give us here our log 1 all over 2, then all over our log 3 all over 2 base 10. This is base 10. Okay, we apply what we call the division law of logarithm, because this is division, this is division. So what does the division law of logarithm say? It says that if you have your log, your m all over n, this is equal to your log, your m, then minus log, your n. Okay, so applying this, we're going to have this to be our 1 all over t. This is equal to, we're going to have log 1 base 10 minus log 2 base 10 all over our log 3 base 10 minus log 2 base 10. But we all know that log 1 base 10 is equal to what? 0. Yeah, it's equal to 0. The law which says that if you have your log 1 base a equal to 0. So if we apply this law, this will give us 0. So we're going to end up having here 1 all over t is equal to our minus your log 2 base 10 all over our log 3 base 10, then minus log 2 base 10. Okay, here we have to look for t, right? Good. So we cross multiply. When we cross multiply, we divide. Or better still, we take the reciprocal of both sides. So if we take the reciprocal of both sides, what will this give us? Let me erase this. If we find the reciprocal of both sides of the equation, so we're going to have here our t will now be equal to this will give us log 3 the base 10 minus log 2 base 10 all over our minus log 2 base 10. Now look at this. If we simplify this, this is going to give us our t is equal to, here we are having a minus. And so we can split this. If we split this, we are having a minus sign. This minus is affecting everything. And so this is going to give us our minus log 3 base 10, then times minus, that will now give us plus. And if we divide it down, then we're going to end up having our plus. So we're going to have here 1, then minus our log 3 base 10 all over log 2 base 10. So this is the final answer for our T2. So this is the value of T2 that we plug into the equation will give us the approximate value. Meanwhile, this will give us the exact value. Our T1 will give us exact value. Our T2 will give us an approximate value for this. Okay, so this brings us to the end of this math class. If you learned something from this video tutorial, however simple it may be, give the video a thumbs up, leave a comment in the comment section. See you in our next class. Bye for now.